This video is going to be about the commutative property, and we're also going to talk a little bit about exponents. So the commutative property basically says that it doesn't matter what order you add two numbers in, you get the same result. So one example of that is if you add 2 plus 3, you get 5. Also, if you add 3 plus 2, you still get 5. So in general, a plus b equals b plus a. So it doesn't matter if you add a and then add b onto it, or if you start with b and add a onto it. So here's a little example, and so why don't you just pause the video for a second and give this one a try, and then start the video back up. Okay, so now we're going to add 146 and 875 together, and I'm just going to pull up my calculator. And when I add 146 plus 875, I get 1021. And this time I'm going to add the other way. I'm going to add 875 plus 146. And when I do that, I still get 1021. So this is just showing that the commutative property for addition is true. Now in this little table, go ahead and pause the video again, and this time I want you to come up with an example for subtraction, multiplication, and division, and decide for yourselves whether the commutative property works for each of these operations as well. So just take a second, pause the video, and then start it back up to see if you were right. And we'll have different examples, but our conclusion should be the same. Okay, for subtraction, the example that I'm going to do is 15 minus 10. Is this equal to 10 minus 15? So when we do 15 minus 10, we get 5. But now if I do 10 minus 15, so here we're starting, it's like you have $15 and you owe somebody 10, and so when you give them 10 of the $15 that you have, you still have 5 left over. Here you only have $10, but you owe someone 15, and so you still owe them 15 when you're done, and so that would be represented with a negative 5. So when we do subtraction in the opposite way, then we don't get the same result, and so subtraction does not commute. What about multiplication? So we can use the same two numbers, or we can come up with some different numbers. So let's say we did 3 times 5. Is this the same as 5 times 3? Well, when we do 3 times 5, we get 15, and you can check that on your calculators. And then if we do it the other way around, whoops, 5 times 3 is also 15, and so since it's true, and I'll put a little question mark on top of my equal sign because this is a question I'm asking, and so here we see that it is true, they are equal to each other, and so multiplication does commute. And so it doesn't matter what order you multiply things in. It does matter what order you subtract things in, however. What about division? So I want to pick some numbers that divide nicely, and so we could do 15 divided by 3. Is that equal to 3 divided by 15? So 15 divided by 3. Oops, that's pretty sloppy. Let me fix that. 15 divided by 3 gives us 5. Now if I do it the other way around, 3 divided by 15, let's just pull up our calculators to do that one. And there I get 0.2. And so again, we did not get the same result, and so that means that division does not commute. Commute. Oops, I forgot an M. Addition and multiplication. So it doesn't matter what order you add or multiply in. And does not commute. Would be the operations of subtraction and division. And that means that order does matter. Okay. So now the distributive property, this one's really important as well. And this happens when you're multiplying a single number to a parenthesis, and inside the parenthesis you have a couple of things. So c times the quantity a plus b. When you have that, it means that you need to multiply the c to both a and the b inside the parentheses, giving you c times a plus c times b. It also is true if there's subtraction in the parentheses. You need to multiply the c to the a and to the b, giving you c times a minus c times b when it's subtraction. So again, if you want to just pause the video for a second and try both problems 4 and 5, and then start the video back up, and then we'll go over the problems together. So in problem 4, there's another way to express 27, and that's 25 plus 2, or you could express it as 30 minus 3. I think it's easier to do addition than it is to do subtraction, but we're going to do it both ways with the 27, and then the next problem you can do it whichever way you prefer. So we want to use the distributive property to multiply 4 times 27. And so if you want to do calculations without a calculator, then this is one way to do it. And so the first way we're going to do it is with the 25 plus 2, because 25 plus 2 is exactly the same as 27. And so we would distribute this 4, and 4 times 25 is 100, plus 4 times 2 is 8. And so we get 108. And then you can check that on your calculator to make sure that you really get 108. And when we type in 4 times 27, we do in fact get the 108 that we were expecting. Now we're going to do it with 30 minus 3, and so we're going to, again, take 4 times 27, but instead of multiplying the 4 to the 27, we're going to multiply it to the quantity 30 minus 3. Again, distributing the 4 times 30 is 120, and 4 times 3 is 12. Oops, that should be a minus sign in there too. And if you take 120 and subtract 12, you do in fact get 108. And we already checked this on our calculator, so we know that 4 times 27 is in fact 108. Now we want to use the distributive property to do these other calculations. 7 times 82. Again, I like to do addition, so I'm going to break 82 up into 80 plus 2. And when we multiply 7 times 80, that's 560. And 7 times 2 gives us plus 14. And when you add 560 and 14, you get 574. And now I'm just going to check that on my calculator to make sure that that's really true. And so I want to do 7 times 82. And I do in fact get 574. Now we're going to do the same thing with 5 times 108. And I'm going to break that down. I like to use addition, so I'm going to break it down into 100 plus 8. Again, distribute the 5. 5 times 100 is 500, plus 5 times 8 is 40, and so we get 540. And then just checking that on our calculator, 5 times 108, and we do in fact get the 540. Next, we're going to talk about exponents. So an expression such as 5 raised to the third is called a power of 5. The base is 5 and the exponent is 3. So the exponent is your 3 and the base is the 5 here. Note that the exponent indicates how many times the base is written as a factor. It should say note, not not. Note also that 5 to the third is read as 5 raised to the third power. When a power, also known as an exponential expression, is contained in an expression, it is evaluated before any multiplication or division. So when you have a bunch of operations together, then evaluating exponents comes first. So here are just some examples. So if you want to calculate what 3 raised to the fourth is, that's the same as 3 being multiplied to itself 4 times. So it's 3 times 3 times 3 times 3. And when you multiply that all out, you get 81. 5 squared, or 5 raised to the second, is 5 times 5. And that gives you 25. And 2 to the fifth is 2 being multiplied to itself 5 times. And you could do this on your calculator. 2 times 2 gives you 4. Multiply 4 by 2 and you get 8. Multiply by another 2 you get 16, and by another 2 you get 32. So that is 32. And that is it for this lecture. If you have any questions, let me know. Thanks.